Okay, so today we're doing a lab that Ben Franklin first did in the 1750s. And it was these experiments that helped define our modern understanding of electricity. Franklin rubbed a bunch of different objects together, and he created static electricity, just like you get when you walk across a carpet in the winter and rub your socks on the carpet and maybe get shocked when you touch a doorknob. And Franklin came up with some of the laws that govern this. He realized that there seemed to be two types of electricity. He gave them the names positive and negative, which we still use today. And he came up with a very important principle, which was when you rub something on something else, if one object gets one of the types, let's say negative, the other gets positive. And that's an understanding of what we now call conservation of charge. If one object gained some charge, that meant the other one lost it. But charge is not created or destroyed. We now know at this point that this is because of the transfer of electrons, which we'll go into later. But Franklin in the 1750s, he was 130 years before anyone knew what an electron was. So these experiments were done with no understanding of chemistry at all. So basically what we've got here is I've got rabbit fur and I've got acrylic. This is to replace what Franklin used, which was cat fur and amber. So that's two of the things I have. I have cotton, I have rubber, I have silk, and I have glass. And essentially what we're going to do is we're going to rub these different objects together and we're going to create a charge. And then we're going to use this electroscope. These little styrofoam balls have metal paint on them, so if they get a charge, they will keep that charge and we can use them to check other charges. So the first thing you have to do when you're talking about electricity is you have to have a reference charge. So what's positive, what's negative? Well, nothing until Ben Franklin. He said I need to give one type of electricity one name and another name. So he said when I rub cat fur on amber, I'm going to say the cat fur gets positive and the amber gets negative. And from that initial definition, that's where all our definitions of positive and negative come from. In fact, now we know the electron is negative because we know that amber rod gained electrons. That's where the electron became negative from this experiment. So what I'm going to do is I'm going to rub the the rabbit fur on the acrylic. We're going to charge it up, and then I'm going to give that negative charge to these styrofoam spheres. All right, so I can hear the static crackling. And now, if I go near the spheres, that didn't charge up that well. I don't know why this is easier to do when I'm not filming. There we go. That charged up really well. So now, as you can see, the styrofoam spheres, they all have a charge, and they're all pushing off each other. And they're repelled by the rod because they all have the same type of electricity, the negative electricity. And that's creating a force, and it's a force we can study just like every other force in this class. And it's kind of fun to do this for a while. But since we defined the rod as having a negative charge, that means the spheres do too. And now we can use them as a reference to check other charges. So, for example, if I decide to do cotton and glass, I can charge this up, similar manner. And if it repels like the other one did, then I know that this has a negative charge just like the acrylic. If it attracts, then I can assume this has a positive charge, at least for now. And they appear to be attracted, but only very slightly. That may mean a positive charge. That also might mean the rod is neutral. We'll have to figure out later. Notice I'm trying really hard not to touch these because I don't want to have to charge them back up before I do my other experiments. So anyway, from that initial definition saying that the fur became positive and the rod became negative, Franklin could check lots of other materials rubbed on each other. He could come up with a list of which materials seemed to like to be negative, which seemed to like to be positive, And he was able to build up an understanding of electricity 130 years before we ever knew what an electron was, which is pretty impressive. All right, thank you.